Hi, everyone. I'm Andy Chang. I'm a product manager on Google's privacy and security team. Really happy to be here today to talk to you a little bit about the lessons we've learned from securing Google, from securing Google customers on Google Cloud. So enterprises today are seeing an increasing number of breaches, and the increasing number of breaches are being reported in an increasing number of ways in a larger scope in the public. And this trend does not seem to be decreasing. On a very regular basis, the increase in data, that's sensitive data that's being collected, created, combined with the attackers' increased determination and skill, is only going to make this a larger and larger problem. So on average, an independent study showed that enterprises see almost 1 million events on a weekly basis, and that reduces down to more than 3 actual incidents that need to be investigated, potentially remediated. At Google, it's very important, and we think it's very important, to think like the attacker. So the attackers have a particular kill chain. It's part of Google culture to do red teaming on a regular basis, and it's also part of the informal culture to do quite a bit of white hat hacking. These things allow us to really focus in and hone in on what the attackers are actually focused in on. And so in thinking like the attackers are focused really overall in trying to target identities, the code, the data, the metadata, and the resources. On the identities, the typical things that get compromised are user accounts or OAuth tokens. On the code side, the injection of malware, the actually intersection with even in the changing the binaries, introducing things into packages or libraries. On the data side, just the ability to kind of egress sensitive data so they can use that for a range of purposes. And on the metadata, the look for and the attack on cryptographic keys and secrets. And finally, from the resource standpoint, the really looking at attacking things from either a denial of service basis or subverting and abusing resources for the purposes of creating a command and control infrastructure or botnets or cryptocurrency mining. So all these are really kind of where the state of play is today. Now, at Google, we've been very fortunate to have 8 of our services reach out to over 1 billion users, including Google Cloud. As a result, every moment of every day, we see the full range of attacks that actually are going on and the full range of bad actors. So we see anything from lone wolves and script kiddies to nation-state actors to hacktivist groups trying to attempt to do the range of attacks of phishing, denial of service, malware injections for the full range of motivations. Could be economic motivations, espionage motivations, or just purely for fame. As a result of that, we've had to evolve the culture and the strategy for building security on Google based on the global scale and view of bad actors we get, while maintaining the pace that supports the innovation that the core products within Google need. And as a result of that experience, we've learned a few lessons of how to secure Google and how to secure Google customers and enable them to secure themselves that we'd like to share. So there are about 7 kind of key highlights that we want to talk about today. And the first of those is really defense in depth by default at scale, right? And that's protecting, again, those 3 main issues we talked about. The identities, the data in its 3 various forms, code, user data, and metadata, and then the underlying resources. And then trust through transparency. So not only is it necessary and important to always have leading edge technology, in order to build the trust with you as customers and as partners, we actually need to be more and more transparent about the security infrastructure that we have. Automation of best practices. So on the development side, the ability to take the user out of the decision-making process, that to take developers out of bespoke creating things, to actually automate the practices so that they get the best and most secure things by default. And then similarly, a core part of Google culture is being open and sharing innovation. And that's a core part of the security culture. We very much believe that a safer web for all is beneficial for the masses and for everyone. And our ability to take a number of our innovations and either open source them, open standard them, or make them available to the public increases and raises is the tide that raises a lot of boats. On the user side, it's important to address programmatically common use cases. So again, that we take the user out of the decision process and that common things like patches and updates are clear programmatically and by default. Finally, from a security standpoint, in a public cloud and customer environment, it's important for us to first be clear about where the shared responsibility line is and really to empower our customers to deliver on their part of that responsibility. And lastly, with all these things in combination, trust and security can really be an accelerant to business. And so now I'm going to talk about a bunch of these things in a bit more detail. So historically, users, customers, and partners have really depended on the network as that key barrier for security. And they really had an intellectual model of the villains being kept outside, and then all the targets and things that they want to protect be kept inside. But that model is broken. Today, if someone gets inside or if someone starts inside the wire, there are fundamentally far fewer obstacles, controls, and defenses for them. And enterprises are seeing that in their day-to-day life. As enterprises now perforate their own perimeters to use cloud services, to allow mobile access, this kind of core perimeter model is broken. Now, at Google, for quite a while now, we've not had a perimeter-based model. We do not believe that there is an abstraction that allows you to say there's an outside and an inside. In fact, our solution is a perimeter-less model based on the fact that we can do identity and authentication and policy on each access to every resource. And we've talked about that in our Beyond Corp papers that we've published over the last 3 to 4 years. A key part of that is that many of the services Google delivers are public to the public web by nature. So in order to keep a security level high enough to protect the users using those services, we've had to build a defense in depth at scale by default structure. And we'll talk about that infrastructure in a moment. So the first lesson, integrate the defense in depth at scale by default. At Google, when we think about the defense of our infrastructure, we really think about mapped to 9 layers, from hardware through secure boot to inter-process communications and the curated operating system, to the storage and data services, the network that Eric and Diane talked about earlier today, application-level security, deployment, operations, and all data usage. So at each layer of these, we've designed so that we can have provenance and minimal trust between each layer, which allows us to then know that as an application spins up or as the hardware spins up, it's built on an increasingly trusted and known platform so that when it finally operates, it's operating in the situation where the right code is authorized by the right service, running on the right machine, accessing the right data, at the right time, and in the right context. And that's a core part of every operation that occurs at Google. To dive this in a little bit more depth, we're going to talk about many of the layers that form the underlying layer. So at the hardware level, we're very fortunate that we have a large enough scale that we can build purpose-built hardware. And that means from purpose-built chips, going into purpose-built servers, into purpose-built storage, into purpose-built networking, into purpose-built and wholly owned data centers that we operate globally. After we have the provenance, therefore, on the supply chain of those servers, the next step is to boot in a trusted fashion. So we cryptographically sign the boot loader, all the way up to the basic kernel, and therefore allows us to now have a machine state, which is in a known good state with a unique cryptographic identity that then allows us to determine that it's ready to be joined to the fleet. Once it's kind of at that point, we also have our own curated and hardened version of KVM, which we spent a lot of time through both code analysis, fuzzing, and actually changes and modifications of the code to make sure that that's a secure core basis of our hardware and software infrastructure. We have authentication in a cryptographic way between services at this low level. And then we run a curated image of Unix, again, that's been stripped out, or sorry, Linux, that's been stripped out of many of the known vulnerabilities. In all these cases, the known vulnerabilities we've found, we've also published back out to the security community so that the world at large can benefit from this. So now we're at a point where we have trusted hardware, it's boosted in trusted state, and the underlying host software is something we have high confidence in. At a storage level, we encrypt everything at rest by default in one or more different ways. We have underlying, obviously, disk encryption, hardware disk encryption, but on top of that, at an application layer for all data accesses on Google Cloud, we're encrypted at rest. We additionally encrypt in transit between data centers we own. And we also allow that ability to control the access and logging of the data, so through our set of audit logs and also through a set of internal logging. At the network layer, as both Eric and Diane pointed out this morning, we have one of the world's largest private networks. And what that means for customers is they can connect with us at over 100 different points of presence across 33 countries. And from that point forward, they're on a private network, completely off the public internet, and we can guarantee that end-to-end from where they touch the point of presence to the actual servers and systems that serve their applications. In addition, once you have the network in place, the next piece is really the applications that we build. So within Google, we have a software lifecycle that programmatically enforces peer review, security review, privacy review before one line of code is pushed to production. And in addition, we use static code analysis on our source code, combined with the ability to look at and scan the libraries and the packages that are linked in, so that throughout the build cycle, in the manifest, we have a chain of evidence and a binary signature that allows us to know that our code that's about to be deployed is actually the right code. And this gets back into what I said earlier about making sure the right code is running on the right machine, which has an identity, authorized by the right service or user who has an identity with those right permissions, accessing the right data at the right time in the right context. Once we're through with, from an application development standpoint, through the software provenance, through the ability to actually actively scan that software, the next step is to deploy. And at Google, we have a phrase that your first users are typically abusers. So there's always the opportunity, as soon as you deploy code, to see from a different set of ways the attackers trying to find ways to actually breach the actual software that you're creating. And there are a number of things we do on the deployment side. First, for users, we enable them to have a hardware phishing-resistant two-factor authentication. We enforce that all of our employees with access to anything at Google use that same hardware two-factor phishing-resistant security key. In addition, all Google services are encrypted through TLS end-to-end. Google, as an overall infrastructure, has a Google front end, which is globally distributed at the different points of presence, but logically centralized. And that gives us the ability also to, by default, have built-in denial of service DDoS protection for a number of things like SYN flood, a lot of the volumetric attacks. And as a cloud customer, if you use one of the load balancers product, you're also protected behind that, as well as if you use our platform as services, such as App Engine or BigQuery, or software services like G Suite. Those are automatically protected from DDoS attacks. In addition, we've invested in further in the actual encrypting and certification of traffic between endpoints through certificate pinning, which prevents man-in-the-middle attacks, as well as moving forward the work that we're doing in an open way around certificate authorities, which allows you to have an open record and make sure that if a particular CA gets compromised, that won't then be able to be injected in and create another vector for folks. So once things are deployed, now we have to operate them. And one of the core parts of Google and our infrastructure is that we have the underlying infrastructure from the host side automatically patched and updated. And this is something that customers don't have to provide maintenance windows or see downtime for us to do if they opt for our live migration. Because everything at Google runs on a uniform substrate, we're able to live migrate user information around while we're making either maintenance changes or, importantly, these patches and updates that make sure everything stays current. In addition, from an operations standpoint, we have our own threat analysis team, which focuses on the type of attackers that we see targeting Google, the advanced persistent threats, looking at the full range of data we have at Google, and looking at the signatures and the modes that they use so that we can better protect ourselves and our customers' data. And we have both a pre-fail team focused on security engineering and proactively and preventatively securing our applications, as well as a post-fail team and incident response focused on actually investigating and taking those millions of events and turning those into deciding whether those are incidents that need to be explored or not. Finally, from a usage standpoint, as the applications are used, we have the ability through, again, the data that we collect to look at login reputation, to look at URL reputation, in-app reputation, and things like Android store, so that we get a full sense of what actually is potentially a good binary versus a bad binary, what's good behavior versus bad behavior. And from a Google Cloud standpoint, we provide audit logging for both access logs as well as admin logs so that you as a customer can see what's also going on. So as a part of this then, in addition to the technology that we've put in here, we've also continued to invest in the people. So we have 700 plus software engineers and security engineers solely focused on securing Google and Google customers on cloud. And then it's the combination really of the technology and the team that continues to allow us to deliver security at a high level of standard. In addition, if you want to learn more about our infrastructure security design, I highly recommend that you attend Niels Provost's talk tomorrow at 5:30. It's session IO 243, and he'll go in even more detail around our infrastructure security. So again, the first lesson from securing Google and Google customers is it's important to have integrated defense in depth at scale by default, which means that from an end-to-end basis, you can establish provenance and you know exactly what code you're running and you know what your known secure state is. So lesson 2 is, in addition to the technology we just talked about, and that's core, right? It's a necessary condition to have leading technology from a security standpoint. For you as a customer and you as partners to trust us, we believe highly in trust through transparency. And what that means is that, and it's a part of Google's security culture, that whenever possible, we allow you as the customer and the user to decide for yourself and have visibility in what we're doing so you can make decisions and draw your own conclusions about how we're running things and whether it's appropriate to your business. And some examples of this are our transparency report, which gives on a regular basis a view of how legal and public actions affect sensitivity and access to information on the internet. In addition, we have an ongoing and recurring effort for increasing certifications so that, once again, you can either inspect yourself or you can trust and invest in a third party that has already validated what we do. And this spans the full range of ISO 27001, 27017, and 18, SOC 1, 2, and 3, FedRAMP for a number of our services, especially G Suite, the ability to do model contract clauses with customers, and the ability also to sign BAAs for HIPAA for a number of our services. And this is an area that we're going to continually invest in and increasingly invest in for the additional certifications that are prioritized by our customers, matched to what they need for their business. And also from a trust and transparency side, another piece of how this is aligned is to the SAP announcement that we made this morning as well. With partnering with SAP to deliver governance, risk management, and compliance solutions, and also partnering with SAP so that SAP can become a data custodian of data on Google Cloud. The third lesson is really around automating best practices to prevent common mistakes at scale. So as I mentioned earlier, us as humans are the source of many of the potential issues and problems. And so from a development side, it's very important for us to automate as much as possible and abstract out the decisions and choices that our developers have to make that may lead them to create a less secure state. As I also mentioned before, most of our services that we deploy in the public are at the web application level, so at the L7 level. So a common area of concern and prioritization for us is in cross-site scripting. So as an example of some of the automation that we've done, we have frameworks and we have secure coding practices, combine those with automated scanning. And what that's allowed us over a 4-year period is reduce cross-site scripting errors by over 30%. And for some of our billion user applications, that's reduced cross-site scripting vulnerabilities down to near zero. The fourth lesson, and this is again core to Google, both from an innovation and open source standpoint, is really to share innovations to the wider community and really raise the bar and lift the tide so that the web becomes more secure for all. Some examples of this, Google has for a long time been a contributor to security and a leader in the contributions to security. Going back to TLS and the safe browsing interface, our vulnerability rewards program, which started back in November of 2010, has to date paid out over $9 million to security researchers who have found various things and helped us improve the security of our own platform. The security key technology that I talked about in combination with the FIDO Alliance to again provide a phishing-resistant way that combines from a user experience low effort and a high security ability so that it actually will be used and secure our users and employees. Project Zero, which is an independent effort within Google, which looks for O-days and third-party software and has been instrumental in driving fixes to some of the key vulnerabilities that have been found. And recently, over the last year, we've actually open sourced our vendor security framework to allow you to actually take advantage of some of the controls, some of the ways we think about things when we engage with vendors at Google, to actually allow access to our Chrome fuzzer so that you can use the infrastructure from a fuzzing standpoint, and also from an IoT beacon standpoint to extend from an open format standpoint a secure and privacy-preserving beacon format. And the one thing also I'd mention back in for our work in KVM, each of the bugs that we found in the KVM, we've actually, again, externalized and made available to the security community so they can benefit from that. And I think to date we found about over 2/3 the actual publicized bugs that have been found in KVM. Third, from a fifth lesson standpoint, it's also from an operational standpoint to address common use cases programmatically. And some of the key examples of this is that while there's a lot of press today around 0 days and around very sophisticated advanced persistent threats, most of our customers and most partners still have a lot of potentially basic hygiene security things that can be addressed, such as patching and updating and what users do to secure themselves. An example of our philosophy around updates and patching is this is the last 3 versions of Chrome that have been released since September. And basically what you see on the x-axis is the week in which the week by week of the year, and on the y-axis, the percentage of adoption. So within the first week of each of the launches of our updates, the majority of the 1 billion plus users are updated to the new version. And that's a core part of both our Chrome and Android approach and also our approach to patching in our underlying fleet, is that it should be an automated process, it should happen by default, and therefore people get to be secure by default without having to take any additional effort piece. The next piece is focused again around users. As I mentioned before on the development side, us as humans are some of the weakest links, and similarly on the user side. Users and phishing is the most common way that breaches start. And again, talking to one of the key solutions that we helped bring to market is really the phishing-resistant hardware two-factor. You'll be hearing more about that in the rest of this conference. And that's something that, again, as employees of Google, it's required. It's how we access and secure ourselves to any access at Google. And it's something we highly recommend that the admin accounts at any of you as users or anyone on Google Cloud also use this phishing-resistant two-factor solution. In addition, you'll see most of us at Google also use Chromebooks, and Chromebooks are another way that by default you can be secure. Right? Chromebooks there's no way to download software onto Chromebooks. So if you think about hardware-resistant two-factor, the ability to eliminate the ability to install malware on your machines, those are ways by default again that the community in general can be more secure and eliminate one of the easiest attack vectors. So lesson 6 really is around empowering customers to fulfill their responsibility in the shared responsibility model for security. So for most of you in the audience, you're probably very familiar with this. This is the 2011 Lockheed Martin kill chain for attackers, which really looks to provide how the attackers think about ultimately getting to their objectives. But to date, there hasn't been a similar common view of what the defender kill chain looks like. Some of the initial work on that has really focused on post-fail, right? Really on what happens between the monitoring and detecting, the ability to alert, and then the actions thereafter. If you break that out some more, looking at just the post-fail piece, work recently at RSA from Microsoft has further expanded some of the response choices and giving us more process and more framework around what folks do on a response basis. And if you look at the original work from Lockheed Martin, that also really focused just on the response side. So what we can do to the attacker kill chain to either detect it, deny it, destroy it, deceive it. But traditionally, most of these things have come from the old world where a company has full control of its data centers and its infrastructure, and really there's only one organization that's involved in handling any incident. As we've now moved to kind of public cloud and a cloud-based world, there are two things that additionally need to happen. One is increased, in addition to that kill chain, on the pre-fail side, and having that as an integrated part of the overall decision on the defense side. So in addition to the post-fail reaction, how do we, together with our customers, assess and provide the right assessment of the attack surface? How do we actually specify and define what the secure baseline is and have that enforced across on-premise, hybrid, and multi-cloud? And then how do we protect those uniformly too, so there aren't any chinks in the armor, irrespective of what the infrastructure is? And then that feeds into the protection, detection, alerting, and response. And on the back end, one key thing that historically, again, has not been focused on, but is more and more important, is the communication aspect. Historically, when we talked about incident response and detection response, it was, again, within one organization. And so the sausage making was really hidden. At this point in time, when customers have a shared responsibility on cloud, the distinction, the communication paths between the customer and the cloud provider need to both be programmatically and processed from a standpoint evolved so that they actually meet the needs on both sides. And the last thing is really the opportunity to learn. So as both Diane and Fei talked about this morning, we're in the age of machine learning. So the ability to take the data that we now have across the cloud that you have as customers and use that to integrate both in learning on the pre-fail side, in the detection side, and the response side is a great opportunity. So what we want to do now then is connect this defender kill chain, this extended defender kill chain, with those targets I talked about in the beginning, right? So attackers are looking to get at, again, identity, code, data, metadata, and resources. When you combine this, you can create a framework which really looks at the intersection of the two, both in pre-fail and post-fail. And now we can have a very, very clear discussion between cloud providers and customers about where the shared responsibility sits. So some of the key places this sits, if you think about where audit and compliance sit, they sit around in the pre-fail assessment and specification phase. That's what a lot of audit and compliance is about. In addition, security engineering sits in similarly how to define from your development cycle the things that make your code and your system secure by design. When we cross over the post-fail side, that's really historically been the role of security operations, the SOC, and the detection response teams. However, one thing you'll note purposefully is I haven't created an overlap between those. And that reflects what life is like today, but that's one of the things that needs to change as we think about how to do end-to-end security operations similar to how folks ended up doing development operations. Right? That overlap of understanding what you specify gets turned into what you monitor for, gets turned into what you detect, and what you're able to then respond to. And as I talked about before, there's a huge opportunity from the learning side across all of these to feed into the growth of this. So let's take a test drive of this and practice, and what does this mean? So key intersections, again, audit and compliance, security around each of the things, for example, security engineering around identity, how does that become a shared responsibility, around policy specification and enforcement, vulnerability management, data protection, logging. Those are the common topics that come up in the shared responsibility. And from an operations side, the communication and learning pieces. Now, when we map this to identities, what we have here then, just to orient you, is right to left, on-premise, through to software as a service. So the abstraction, the sense of control for the customer is going most on the right, least on the left. And then in the y-axis, the stages of the kill chain, from assess all the way down to learn. The color codes are what the provider typically manages in these situations versus on the green side, what the customer manages. And then the gold areas are those opportunity areas where even though this is a customer responsibility and customer managed thing, there's is where either providers or partners can help the customer achieve their shared responsibility. So what does this mean in practice? So from an identity standpoint, assessing the strength of your identity and how your identity solutions, that's squarely on the customer. That's not something that really cloud provider decides. But enabling the customer to then understand and specify what's the secure baseline, those are opportunities for the cloud provider and or partners to help the customer understand what their secure state is, what the baseline is, and do the reference from that. As you can tell, as you go from a software as a service where very little is in the direct control of the customer, and the customer is really using software created by the provider, there's a lot that's not the customer's responsibility. In the platform as a service case is where that gray area, there's a number of things in the specify and protect side that end up being the customer's responsibility, as well as that, in all cases, that opportunity to learn. And where most of the folks doing traditional lift and shift are obviously in the infrastructure as service. And throughout the spectrum, besides just the assessment side of identities, the ability for us as the cloud provider or our partners to help customers fulfill their responsibility spans the whole spectrum, and including a responsibility around the communication and the underlying learning pieces. And this kind of pattern is largely the same from a data standpoint. The additional opportunity from a data standpoint is that the cloud providers, and we talked about this earlier in terms of a content awareness, have the ability to also assist customers in their ability to understand what data content they have, what the policies they are, and I'll talk more about that. And finally, from a resource standpoint, so if you're talking the underlying resources to deliver services on a software as a service basis, for example, something like Drive or Gmail, the customer really doesn't have responsibilities to protect those resources. Those are auto-scaled resources that the cloud provider is managing. Similarly, in the platform as a service, these are operationally things that the cloud provider provides. Once you move to infrastructure as service throughout the full spectrum, as a cloud provider and with our partners, we have the ability to assist you as a customer about how you want to run and secure your resource infrastructures, whether it's against denial of service, whether it's against abuse, and those type of things. So kind of the last lesson is to take that shared responsibility model and talk about what does that mean for creating a trusted underlying infrastructure for you as a customer. And they're really focused around three things. Context-aware access, so getting back to what we talked about within Google, we do the right code is running on the right machine, authorized by the right user, running at the right time, and in the right context. Being able to externalize that for you as customers to be the same type of access control that you guys provide. From a content-aware standpoint, the ability to not only look at data and think about the encryption of it, but also think about the classification of it, and also differentially both specify and enforce policy against that data is an opportunity that exists now in the public cloud as data gets moved to that. That's much harder for you guys to start in practice in your existing on-prem infrastructures. And lastly, platform trust, and we'll talk a little bit more about where we're thinking further on the platform trust side. So, trust and security historically have been looked at as things that slow down innovation. Our firm belief at Google, and it's something that we've lived through keeping up with the velocity of our production teams, is that once you have the right set of trust and security by default, you actually accelerate innovation because that allows developers to focus on their kind of core practice, which is delivering and building great applications that drive business, and that the underlying infrastructure protects them and protects their applications. And Eric talked about this earlier in the keynote. That is the model that we use at Google. That's the model that we think will, in the long term, be the right one for folks building businesses. In order to do that, the three components that we see really are context-aware secure access, so really extending beyond this perimeter model to allow individual resources to have policy applied at the moment of use against their identity. Content-aware data management, so as you all know, the nature of the data, what's actually in the data, typically dictates its risk. So being able to make users and customers more easily aware of what that content is and manage that so they can manage the differential policies. And from a platform trust standpoint, the two kind of key principles. One we talked about before, which is the trust through transparency. The more we're able to show you and have you validate what we do, the higher level of trust that you'll have and ability to run your businesses on our platform. And also enabling minimal required trust. So how do we increase the portfolio of items that you can choose to do without even having to trust Google or the cloud provider? So these are the areas that we're looking at kind of moving forward. So kind of in summary, defense in depth is really around allowing the infrastructure to be secure by default, and then allowing users, developers, clients, and partners to really focus on what they do best, which is creating what's next and building businesses. The trust through transparency piece enables you to see and verify for yourself, and therefore make decisions in an informed way about whether you want to run certain business processes and workloads on certain configurations. Automation abstraction takes humans out of the process and creates repeatability and deliverability at scale. Our core values around open sourcing and sharing innovation are really around uplifting the whole internet and making it safer for everyone. And then from the user standpoint, to take again that decision-making and choice out of things like updates, patching, access, so that the common use cases are addressed programmatically and folks are secure by default. Empowering customers to secure themselves, so being clear about the shared responsibility model, enabling kind of a successful shared responsibility by providing a full range of services that allow customers to deliver on their part. And lastly, to accelerate and continue to use security as an accelerant, the ability to focus on context awareness, content awareness, and then platform trust. So, a core part of where we are as an enterprise, working with enterprises, is not only to enable you to kind of get to where you want to go, but to start with meeting you where you are and then taking you beyond where you can imagine.